Well, unless you have a Moodle, right? If you have a Moodle page set up, the enrolled students, you can mail them directly.
But it doesn't go to their email.
Yes, it does.
Okay,
It does.
thank you for coming. This is the first invited speaker for the series of lectures for first year students, but it's open to all years, and we have invited, I see, around several third year students. And today we are lucky to have Massimo Bombino. Massimo Bombino is yet another Italian, in addition to present as myself. But most importantly, he has 20 years experience in working with safety critical software, embedded systems, and he works for Vector Software, which is a US company, also based here in London. So he will give us a talk on software for mission and safety critical applications. It's probably going to take some time. So if you can leave a bit of time for questions.
Yes.
And thanks.
Okay, good evening. My name is Massimo, as Franco said, and I'm going to introduce you to safety critical software or mission critical software. What is most important is safety of the people. So we are going to not murder our customers, because our customer will be not happy if we try to kill or to murder them. So the idea is to select a direction when you go on the software development activity. If you want a cheap, quick and buggy software, like most of the commercial software you can find on your PC or on your smartphone or your own car, Volkswagen Golf and what happened recently. Or to have a very expensive, very expensive, safe and almost correct. So you cannot guarantee 100% correctness of your code because it's too complicated. There are some formal methods that can guarantee you some properties, not like the formal correctness of everything. Some properties could be demonstrated to be corrected, but it's very difficult. So in general, we do what we call testing, verification activities, for different environments, for avionics mainly, for medical, railway, automotive, and nuclear, of course, nuclear plants. Okay? So there are some paradox. If you try to build an iPhone or a Samsung with all the criteria of safety critical software, like the standard that we are going to introduce, the DR178, the cost of a device, of a phone, will be several thousand sterling, pound, dollars, euro, whatever you want. Something like this. Someone estimated the cost of development and the cost of a real device, not the total cost, the cost of one device. Vice versa, if you try to develop your software of commercial smartphone, the approach you use with the commercial smartphone to an airplane, probably you would have several crashes every day. So there is a choice to be made. So software is one of the biggest problems recently. It's more and more a software because the number of software line of code is increasing in every device. I have in my car, it's a Volkswagen Golf, apart from the emissions, I have a handbrake that is a button, okay? So it's a button that you push the button and you release the handbrake. If you pull the button, then you engage the handbrake. The first time I was using the car, it was a problem because I was not understanding exactly how it worked. Okay, you have to press the brake and then do this operation. But there was something strange because sometimes the car was disengaging automatically the handbrake, sometimes not. Then I just noticed that was due to the seatbelt. If you fasten your seatbelt, then automatically the handbrake is disengaged. And vice versa, when you park the car, when you release the seatbelt, automatically the handbrake is engaged. Okay.
So you can't do all these stunts of quickly turning the car while
you
you're
cannot
driving.
do the U-turn very quickly. No. With the snow. But the big problem, the first question is, the first time I was in the highway, I was trying to catch an object that was falling down, and I said, okay, I will unrelease my seatbelt. And then I said, oh my God, what happened to the handbrake now? There should be a highly critical device, software, hardware, etc., checking that if you release the belt, the speed must be 0. Otherwise, you have a big problem with the rear tires, with the rear wheels blocked. So, and this software should rely on a sensor, on a speed sensor. This speed sensor should be something that could fail, okay? And if it fails, you will maybe say that the speed is 0. So also the sensor should fail in a correct way, telling that, oh my God, I'm failed, okay? And then you don't trust anymore the sensor, or should give you a correct answer. So it's much better to say, I don't know, than a wrong answer. A wrong answer will kill you. A wrong answer will crash a plane, okay? Suppose you have an altitude sensor to your plane, and the sensor says that you are at 3,000 meters, okay? Suddenly it says 1,000 meters. Okay, what happened? Is the sensor broken, or you are descending very quickly? It's not easy to tell, okay? So the sensor is much better that says with a cross red, I am not working anymore, I am broken, and you don't trust anymore the sensor, expected to give you a wrong answer. If you add a second sensor, do you think you improve the situation? 2 sensors is better than 1, in theory. But if one sensor tells you 3,000 meters and the other one tells you 1,000, what is the correct answer? There isn't. Okay, you need 3 sensors. Or something else, maybe the history of the altitude. So if you look with a graph with the history of the altitude, then you can check that your plane is not descending very quickly, but it's the sensor that is giving random values. Okay? So in general, the software is very expensive. So it costs several billions of dollars only in the USA, and more than 500 billion in the world. And a lot of projects are cancelled due to the poor quality. We will see an example later. The Joint Street Fighter has a very big delays due to software problems. Another good example is will be shown in the next slide. Is the Airbus A380. It costed a lot of money, much more than expected, due to a very, very stupid thing. The people in France were using a CAD, a 3D CAD that is called CATIA, version 5. The people in the other country were using CATIA version 4. Different way of calculating the radius of the cables, etc. Finally, in the prototype, in the first prototype, they found that the cables were shorter for a few centimeters. So, and you cannot connect together the cables to wire your plane. So it caused several months or maybe more of delay just due to different version of a software. And it's very stupid because in a project you should have one version of a software, not a different version. But even Airbus, one of the biggest producers of aircraft, did this error. So more and more the people, especially at the higher management level, are worried about this, and you need some way to improve the quality of your software for safety critical applications, avionics, medical, railway, automotive, nuclear, etc. So, how many people are killed for plane crashes? So here you see the number. Initially, very few planes. The number of planes are increasing, and so the accident and the quality is improving. So you should also compare this graph with the number of line of code that started to 0 in 1940 to the actual 100 million in a commercial airplane. 100 million, okay? So the number of accidents is very low, and in fact there are very few, but really very few, just 1 or 2 fatal accident only due to software. There are mixed motivation, human factor, software, hardware, etc. But only due to software, I think there is only 1 maybe, or maybe 2. Okay. So, and of course the air traffic growth. So you should add this graph to the previous one. So you should see that the number of hours, the departures, etc., are increasing very rapidly during the last 40 years. And also the accident rate, so if you calculate the accident rate, is low and very low. It's one of the safest way to travel the plane. Where are the fatalities? Most of the fatalities are during the initial phase or the final phase. Okay, you see landing, 25% of fatal accident, taxi and load, takeoff. During the cruise is not very common. Okay, so some numbers. We started with the Apollo landing with a 2 MHz computer based on RTL logic, 16-bit words, 2K of RAM and 36K of ROM, with 200 engineers. So every engineer was knowing very well the code, because he has control only of a few hundred of line of code. Okay. This nice lady, was the software leader of the project. She wrote most of the software for the Apollo landing, and she also invented one of the first virtual machine, because the set of instruction, or the first compiler, let's say, the set of instruction of the processor was very limited. So she invented another language, another assembly language, to be interpreted by the computer. Okay? Margaret Hamilton. Maybe someone of you will become the new Margaret Hamilton. Okay? Or the new Steve Jobs. Or someone of So the joystick fighter is a good example of the complexity, because we are talking about 24 million lines of code. Not only on board but also of support, with more than 500 engineers. Even the number of, if the number of engineers is increasing, you see that the amount of line of code written, or better, they are not written, because they are often generated by a model-based tool, is increasing very, very quickly. Okay, if you go to the A380 Airbus, we are talking about more than 1,000 people, but also we are talking about 100 million lines of code. So there is no way that an engineer has a real control of the software he wrote. Probably because also, as I told you, the software is automatically generated. There are some model-based tools that will automatically generate the software. This is an example of the A380. There are more than 100 systems. System with a mix hardware and software. Not commercial software, not commercial hardware. So in a plane you will not find commercial software or something, because the way you design the software and the hardware, etc., is completely different. Completely. Okay? And the cost, of course, is completely different. Okay, so what is the DO-178? This is one of the main arguments of today. The standard for certification for avionics. It was invented in the 80s and is one of the best standard, or one of the worst standards, according to your point of view. Okay? But it's the actually reference for the avionic industry, and it's more and more used also in other industries. There is the DO-178 for the software, and the DO-254 for the hardware. It's regulated in USA by the FAA, the Federal Aviation Agency, and in Europe by the EASA, the corresponding agency for the European Community. It is required for an aircraft flying in commercial US and Europe sky. Okay? So if you want to have any piece of equipment flying on board on an aircraft, it should comply with the DO 178 and DO 254. And it covers the full engineering life cycle, not only software development, but planning. Planning is very important. A lot of time is spent on planning, okay? Plan before, and then you have to work less later, rework less later. Configuration management, quality assurance, development, testing. And then the development activity, requirement, design, and implementation. And the most important part, the testing and the verification. One of the most common questions when a company asks us to have consultancy, mentoring, tools, etc. for a new project, for a new avionic project, and they don't come from the avionics, maybe they come from other industry, is how difficult it is to develop, to write the software for the O178. The answer is no, it's not difficult, the part of development, but the real part is the verification. You spend much more time for verification activity than for development. You spend about 70–80% of your time just verifying, just reviewing, just testing. What have you done? Reviewing the planning, reviewing the requirements, the design, the implementation, testing, etc. to reach the final certification. And then when you reach the final certification, then you have to lock completely your device, and you cannot add a single bit. You cannot change anything. Okay? You should stay with the exact configuration and the exact software loaded. Okay? So this is because the software could have effects on the safety. So you can have latent errors in the data on the executable, and they could cross the boundary of the software, could create a fault that could create a system failure, and then could create some problem at aircraft level. Okay? So the idea is to go from this situation that is very common in most of the companies. So you do the requirements, you do the design, coding, documentation, testing, and introduce errors. When you find the errors, when it's too late, when you are doing testing and you are doing maintenance, so when you are in the field, okay, for example, or in the latest phase of development. So if you have 2 million cars to recall, or maybe 20 million cars, like in the Volkswagen situation, to recall and update the software will cost a lot of money. Okay? If you check the software, if you verify the software before, during the development, so if you go to an ideal situation, this is a utopistic situation, you check and discover the defects immediately. You introduce a problem here and you detect immediately. You introduce a problem in the design and you detect immediately. This is the utopistic situation, to check immediately and to solve the problem as early as possible. Okay? So the idea is to abandon the wishful thinking and to go and follow a dedicated process for safety. The idea is that the O178C is not the best standard, it's the worst standard except all the others, like the democracy. Okay? So the idea is to improve your process. What we guarantee with the O178 and the similar standard is not the quality of your product. Okay? I think you have IKEA stores in London, and if you go in the front of IKEA stores, you may find some seats with a piston and a counter. So it's simulating a person of 80 kilos sitting down maybe 10 times per day, 20 times per day. Okay? So you calculated, you are engineers, so you calculated the number of time and the number of years that the chair will last, will be efficient. Okay, This is something that is called MTBF, mean time between failure. So my chair, my IKEA chair, will fail in 10,000 years. And you are happy because it's a good investment, okay? For software, it's not possible to do this kind of calculation. It's completely impossible. If you go over a few lines of code, over 100 lines of code, it's impossible to calculate if there are errors, first, and second, it's impossible to calculate a MTBF or a similar value. There is no probability of failure. No, there is a probability of failure. FAA, the Federal Aviation Agency, is very clear about this. What is the probability of a software failure? It's very simple. 100%. It's easy. The software will fail, and you have to be prepared for this. Okay? So the purpose of the DO-178 is to give you process assurance and not product assurance. So you ensure that you are following the right process. So the people from the certification authority will complain if you don't follow the process. Will not complain about your design decision, how you develop your software, etc. But if you don't follow the right process. This is the standard. It's not freely available, but maybe you, as a university, you have access to special conditions, or maybe
we may have access through the library. Yes, I need to check.
I don't suggest you to read it because it's really a waste of time to read it, because it contains very, very few concepts, and especially it doesn't give you answers. Just to give you suggestion, guideline. This is due to the national sport of USA. So you know what is the national sport of in the United States? Yeah. Lawsuit. Going in tribunal because someone is suing you in tribunal because you killed your family. So the idea is to don't give exact requirements in order to avoid any kind of legal action against the owner, the writers of this standard. This is why the RTCA, the group of mixed authorities, aviation authority and companies, lost 0 suit in tribunal. Okay? No suit in tribunal. So they are consideration and not the requirements. A mixed committee of companies and people from the certification authority. And there are different levels. Okay? There are from level A to level D. We will see what it means and why we have safety levels. Okay? So the idea is to have this software consideration in airborne system and equipment certification. Was started in 1980, and we are at the 4th version. Okay, now we have the version DO-178C. Okay, there are many compromises to satisfy different goals. It's not a recipe book or a how-to, etc. It's a discussion flow for guidance. So it's just give you general consideration about how to implement your software development. Okay. And so the idea is to avoid the lawyers to bring you to the tribunal. There are some collateral standards that are ARP for safety assessment and ARP 4750A for system development. And then you have the DO-178 and the DO-254. The safety assessment is one of the most important activities we will talk about. So, 4 versions, started in 80, and very often the motivation to a switch to a new version are fatal accidents. In avionics, you learn a lot from accident. The most advanced feature in the plane, or the most advanced in the standard, were due to fatal accident. This is where the origin of the defects are coming. from different sources. So you could not concentrate only on some of these aspects, but you have to cover all the aspects. There are 71 objectives that you have to comply with the O178, and it's very clear the importance of the objectives if you think about a chain. If you have a chain with the 71 ring, which one is the weakest ring? Everyone. Each one. So there is no weakest ring. You have to build the ring, all the objectives, comply with all the objectives in the same way. So safety is very important. Do you think this is safe? It is. It could be. It could be. Safety is a very strange thing, because first this is not the pilot, but it is a co-pilot. The real pilot is inside. In the picture, it's not easy to catch, but it is inside. So the pilot is continuing to do to fly. Second, this is a test. This is a test. So they switch off the engine and they are trying to start the engine manually. The co-pilot is starting the engine manually. So it was a test. So probably it was safe. It's something that could happen in a plane. In a plane you could lose your engine, and there are 2 engines or maybe 4 for this purpose. Okay. Okay, this picture is quite complicated, but the idea is to show the V-cycle of development, starting from aircraft requirements, system requirement, different system in a plane, item requirement, software design, hardware design, and the O178 and the O254, and then integration and verification, integration and verification, integration and verification, until you do the first flight of your new plane. Okay, I can switch. Okay, the main activities, as we said, are the planning process for what concern the activity that you are going to do, configuration management, quality, software development, verification, and so on. Development, but especially you see the biggest box is the correctness. And this is in scale. The amount of correctness, or the amount of verification, is the most important part of your software development activities. So the key attributes, just to remember what are the key attributes of the O178 are the relationship with the other standard. It's very important to don't think the software alone. You should think the software in the system, in the ecosystem where it will belong. Detailed plan for all the activities, 5 criticality levels, and we will discuss about this in a few minutes. Especially consistency and determinism. It's much better to use an old and proven approach, an old processor, an old algorithm that is proven, than a new approach, something that is not really tested. When you want to use a new device, a new hardware device in a plane, you have to demonstrate that it was used for millions of hours before to use in a new plane. If the first time that it's used, maybe you can switch to older technology. You will not find recent technology, modern technology in a plane. You will find safe technology. That could be maybe quite old. Okay? Because a plane has a life cycle of 50 years. Okay? A plane, more or less, should, from the initial phase of development to the final phase where it's not anymore used, could pass 50 years. Okay? So for 50 years, you have the software, the hardware running, you have to provide support, you have to provide spare parts, and so on. So suppose that you go to Apple or Samsung in 50 years from now, and you ask the spare parts of your iPhone. It's not possible. For a Boeing, Airbus, etc., it is possible. Traceability, everything should be traced. This is one of the most important concepts. So you could not introduce a software that is not exactly usable for a task. Okay? So you could not load libraries that are partially used, or you could not load piece of hardware that are not exactly used. You should use everything on board. Everything should be traced by a requirement. If you don't have a requirement, you have to remove this. Independence, you have different people testing and writing the software. So they should be different. You should test all the possible paths, all the possible coverage. You should qualify your tool, and you should comply with the 71 objective and produce up to 20 different artifacts. But in general, the most important concept is you are guilty until you are proven innocent. So the idea is you have to demonstrate that your software is bulletproof, is safe, is adapted to the level of safety that was determined by safety assessment. Okay, we don't have. Okay, no. So the terminology is certified when a system, a full system with software and hardware is certified. Certifiable when you have a piece of software that is ready to reach the certification. Compliant if you are not following the FAA or the ASA. In this case, your system is compliant, like for example military. And qualified is applied to the tools. This is this sort of snake, is green snake, is the path that is suggested for software development for the O178. So you start with the safety assessment, that is very important activities. Then you start with the QA. QA is the quality assurance. Is one of the most important role in the software development for the O178. Is a sort of director of the orchestra. Then you have the system requirements, plans, standard, checklist, because you cannot trust that someone do a review of your code, of your requirement, etc. You need a formal way to do this. Informal review are not accepted. So in this case, you have to comply with a checklist. There are more than 50 checklists you have to respect when you are following the O178 standard. Then the traceability, everything should be traced. You should not forget anything, and you should not add anything that is not exactly used. And configuration management. And then you have the first SOI, stage of involvement. So here you meet the certification authority. You present your plan, your standard, your checklist, your quality assurance, etc. to the certification authority. And this is the first gate. Is pass or not? If you pass, then you can continue the normal development activities. If you don't pass, in this case, you should go back, rework, and spend a lot of time, a lot of money to be compliant. And then you have higher level requirements, lower level requirements, design, code, logic, etc. And then you have SOI2. SOI2 is stage of involvement number 2, is a development gate. Here you should demonstrate to the certification authority that you are doing well from a development point of view. So you are doing all the correct objectives for the software aspects for the development. Then you have the verification and validation activity, testing, review, and you have the SOI3, where you show your compliance with the verification objectives, and then you have a final conformity review with the certification through the fourth gate. With the fourth situation where you meet with the certification authority. This is how the 71 objectives are made. Okay, this is one of the most important slides that show you why you are reaching a good degree of safety with the O178. It's not because it's perfect, as we said. Only the formal method could give you 100% of the confidence of the correctness of your software. But because you do multiple activities several times on the same data. So for example, you verify your high-level requirement. You verify the accuracy, consistency, compatibility, verifiability, etc. of high-level requirement. But then again, when you write the architecture and the low-level requirement, you should not check only the same or similar objective for this, but also the compatibility and the traceability backwards. And when you write the source code, you could not simply write the source code, but you have to be sure that it's verifiable, conform to standard, accurate, consistent, but also compliant to the software architecture, compliant and traceable to the low-level requirement, and so on. If you counted the number of arrows and the number of these objectives, is about, I don't remember exactly, more than 40. More than 40 objectives are related to verification activities. These are all the verification activities. So you verify the same thing multiple times, and everything that is inherited is verified against the parents. This is why you keep your process safe. You are doing a process assurance activity, not a product assurance like the IKEA seat. This is the process assurance. This is your process. This is how you build a safe software. So for development, you have two objectives for the development of high-level requirement, other three for design, one for source code, and one for executable object code. So a total of 7. For the verification, you have 7 objectives for verify the high-level requirement, 13 objectives to verify the architecture, the design, and the low-level requirement, 9 for the source code, and 5. So this number is much bigger than 7. It's maybe about 40 or something like this. It's 34. Okay? So, what are these levels? This is level A, level B, level C, level D, etc. This, I can show this slide before because it's better. Okay. Is the probability of